Hi, I'm Danielle Peterson from CPD On Demand. Today we are talking to Peter Townshend. He is the Managing Director of Amanziflow Projects, and we will be discussing sedimentation. So thank you for joining us, Peter.
It's a pleasure.
Can you start just by introducing yourself a bit? Tell us about your history and experience working with dams.
Right. Thank you, Danielle. I've been an engineer for about 47 years, graduated from Natal University, and most of the time has been with consulting engineers and some with contracting. In about the 1990s, I had an interest in automatic water control equipment and have been developing that ever since. Most of the equipment is fitted to river weirs and to dams. The cornerstone or the main point of this equipment is that it's totally automatic. It doesn't require any electrical or mechanical means to operate them. And therefore they're pretty unique and very innovative. Certainly we received a lot of interest from engineers, particularly overseas engineers, who find it fascinating that we can develop such equipment here in this country.
Okay, well, with that in mind, can you then talk to us about sedimentation? So what is it and why is it a problem?
Well, sedimentation is a natural process. It's a breaking down of the rocks and the moving of soil and sand, etc., by the various actions of wind and rain and snow and ice. And it's an ongoing process. It's been going for the last 45 billion years, which is the age of the Earth. And why it's a problem is that this is transported by water into the rivers, and that's where it accumulates. The rivers will then transport that down its water course and eventually into the sea, where it forms beaches, etc., unless it's interrupted. And that's what we can talk about in terms of sedimentation. It is a problem, and it will continue to be a problem. It's something you cannot eliminate. We need to find mechanisms to manage it going forward.
Okay, so Peter, what is the current situation in South Africa with our dams and rivers?
We have in the order of 5,000 registered dams in this country, which is a fairly large amount for a country of our size. Most of them were built in the mid 1960s, 1970s, and they form a very integral part of our development in providing storage for agriculture in particular, but also for development. Now, of those 5,000 dams, which are now in the order of 40 to 50 years old, they have accumulated a lot of sediment over the years. And this has reduced the storage capacity quite considerably. And so we're now in a situation where we have these dams and we're now losing some of its original storage due to sedimentation. During the design of a dam, in assessing the yield of a dam, we take into account sedimentation. We know there's going to be a loss due to sediment. But I think with the situation of development we have in this country, increased population, increased water expectation, we have now our storage capacity is dropping, our sediment load is increasing, and so consequently we are heading into somewhat of a storage crisis.
You mentioned in the beginning that sedimentation is a natural process, but can you talk to us a bit about the sources of sedimentation and how human development is influencing it? Right.
Going back to the start of this Earth, which is 44.5 billion years, it was a very inhospitable place to live in. Well, fortunately we weren't around then, but a very rugged terrain, high peaks, deep valleys, etc. And over the course of time, over many billions of years, that has all been eroded down to smooth out the hills and to fill up the valleys, to make our landscape, our earth more habitable. And that is a process of erosion. And that erosion ends up essentially in watercourses. And that is where we now find ourselves. We can be very fortunate for sedimentation to provide us with floodplains, to provide us with material for building, sandbanks, etc. It's a very necessary part of the ecology, sand and mud banks for animals and for aquatic life. So sedimentation is an absolutely necessary process. However, we do, as humans, our human intervention, we have interrupted that, with some of it with dire consequences. Essentially, we have what we have done is we have trapped sediment and prevented it from flowing naturally down the watercourse, thereby accumulating on one side of the structure the sediment, considerable amounts of sediment, but denuding on the downstream side valuable sediment which is necessary. So we have an environmental problem when we put an obstruction, a man-made obstruction, into a natural watercourse. And we need to somehow address that. We've inherited a problem from the past, and how to manage that is something we can discuss a bit further on.
Now, just you have touched on it a bit in terms of, we rely a lot on the water from dams for our own consumption, for agriculture. Now, if the storage capacity in our dams is decreasing, how does that affect South Africa's water future?
Well, not very well, in that we're a bit constrained here in terms of building new dams. We have essentially utilized all our water resources. Well, certainly about 95% of our water resources have already been utilized by existing dams. So we don't have much capacity to build new dams. And so consequently we have to use the existing dams and try and somehow improve the storage capacity of that. And we can talk a little bit just now about removing sediment, but one of the options is to increase the capacity of the dam so that we can either offset the sediment loss, but also we have an increased demand for water in this country, probably more than just the population increase. We, with the Constitution, we try to get water to all our all the people in the country, whereas before water was not easily or readily available on the tap. So consequently, there's a bigger demand for water. Also, with people's living standard increasing, there's a tendency to use more water. The cheapest way, the most efficient way to use water is when you have to walk a couple of kilometers to fetch it and carry it in a wheelbarrow or in bottles. But we also in this country are a little bit of the honeypot of Africa. So we have a lot of people coming into South Africa looking for opportunities. So consequently, our population is more than just a natural birth, and that has been a load on our resources. So all in all, and we'll talk a little bit about climate as well, we are going to be short of water. Another big concern, and probably one of the major concerns, and one of the issues we can address almost immediately, is to reduce the losses that we incur in pipe networks, both in the urban environment and in the rural environment. Agriculture takes about 60 to 65% of all our water. It's a considerable amount, and we need to be more efficient in our agricultural irrigation usage, because there is an increasing need to include smallholder farmers as well, who need water. So generally, overall, there's an increased demand for water. There's a loss of storage due to sedimentation. We also have a very high evaporation rate due to the excessive heat that we've experienced lately.
Yes.
And that's also human intervention because it's global warming. And global warming has increased the peaks, the higher floods, as well as longer duration droughts.
So, I mean, with that in mind, we've seen in South Africa with the ongoing drought crisis in the Cape region. How does a drought affect sedimentation? Does it increase the amount that can run into rivers? So what is the role of the drought and then the flood that generally follows?
Right. Well, global warming, I think, is now generally accepted by all except for one or two people. But nevertheless, I'm sure they'll come around to it sooner or later. The droughts that we have experienced, not only in the Western Cape, it's been in KwaZulu-Natal, it's been in the Free State. In fact, nearly all of South Africa has experienced quite severe droughts.
Yes.
Even here in Gauteng, we were close to quite severe rationing 2 years ago. And that is a natural phenomenon of weather. So obviously with drought, the vegetation cover on the ground gets depleted. It just dies off, and you just have bare ground. And then with that, usually we found with the El Nino effect, that creates the drought. We have the La Nino, which is the female version of the weather climate, El Nino being the male version. And she creates a lot more water. She creates floods. Those floods falling on a sort of denuded surface they easily erode the soil and take it into the watercourses. And we've all seen our rivers flow chocolate brown after floods, and that sediment will accumulate in dams and behind weirs.
And does that sediment have an effect on the infrastructure we've built? Is it damaging? Is it damaging to any mechanical or electrical equipment that's installed?
It's probably its most damaging effect is that it negates the effect of the dam or the river weir. Because of those dams cost a lot of money to build, and that capital investment is reduced quite considerably. Each dam and weir do have sluice gates in, which are there primarily to try and scour out or sluice out accumulated sediment. But unfortunately, they're not very effective in that they are controlled either electrically or mechanically, and they need to be opened by some external source, either human or by electrical motor. And they may not open at the same time as a flood is running. So consequently, the sediment is allowed to settle, and when sediment settles, it consolidates and gets harder. And then it's almost difficult. It's difficult to move it by just sluicing it, using water. And then when you get reeds establishing into the sediment or the mud, they form anchors into it, and then you can't move it. You have to use mechanical means to actually move the sediment, which is a costly exercise, but it's one of the options for smaller dams is to try and remove it mechanically, but it's an expensive operation.
So if we just expand a bit more on that, once the dam has been salted up, what are the options? So there's dredging. Do they raise the dam walls? How do they tackle that problem?
Right. At the moment, depends on the size of the dam. If it's a very large dam, there's not much we can do about sediment which is accumulated at the back end of the dam in the upper reaches. The way sediment settles is it's carried by a river. The river has a certain amount of power in it, and that power, which is really a function of the quantity of water that it's carrying and its velocity, is able to move sediment. But as soon as that sediment or that velocity is dropped as a result of an obstruction, then it starts dropping out sediment. And the heavier sediment, which is the rocks and the stones and even the coarse sand, is usually deposited at the upper end of the dam, and the finer material is carried on into the dam and spreads closer to the dam wall. So there's a profile of sediment as you get through the section of a dam. Once a dam has silted, it is quite difficult, in fact very difficult to recover all that lost storage. For a smaller dam, one could excavate using specialized equipment, which is geared towards working in water or on rafts, but most of it is by dredger, a cutter suction dredger, the cutter meaning to cut through the reeds and things to loosen the material. But that is an expensive operation. There's also the problem of where do you take all the sediment and deposit it. So generally in this country we haven't done much about removing sediment at all. There are one or two barrages where we have sluiced out sediment, the one being the Palabora barrage, where there are a number of large radial gates which are opened in flood times, and that creates a large volume of water going through the gates, and that's been able to transport and to scour out and sluice out the existing mud. However, most big dams don't have that capacity at all, and so sediment just builds up in it. What happens in Japan is very interesting, because they have a mountainous country. They have a lot of boulders and heavy material, sand coming down. What they do there is they intercept this sediment at the top end of the dam before it actually enters the dam, and they create a tunnel right the way around. They bypass like a detour, and they transfer the sediment-laden water down to below the dam. In that way, they're able to keep their dams relatively free from sediment. To do that in this country would be very expensive and maybe not justified. So consequently, the only other option that we have at the moment is to raise the dam to try and offset the losses that we've incurred due to sediment, as well as to increase demand, as well as losses due to evaporation. So a number of dams have been raised. More recently, the Hazelmere Dam near Durban, Belita area, has been raised by 7 meters, and that effectively increases the capacity considerably. It offsets a lot of the sediment loss, but it's an area that's been expanding all the time, so it needs more water. Other dams have been raised. Midmar Dam was raised maybe 10 years ago, 15 years ago, by another 3 meters. So the Department of Water and Sanitation does have a program to address that. They are looking at the Clanwilliam Dam, which is in the Western Cape, but that has met problems of finance at the moment. So there are a number of dams that are potentially due to be raised. The raising, however, is done by conventional means, and that is with concrete spillways, and raising the embankment with earth fill or rock fill or whatever the case may be. so it can be expensive. There are other systems which can also raise a dam quicker and more cost effective as well.
And in terms of raising a dam in the conventional civil method where you're using concrete in that, firstly it's very costly, but do you hit a limit on how high you can raise the dam wall?
There are constraints. There's one, obviously, is the stability of the dam. And often the dam itself needs to be strengthened by drilling and grouting in anchors into the rock and pre-stressing the spillway into that. The other constraint is that by raising the dam, you're also raising the water level, and you're raising the flood level. When the flood comes, it's going to rise even further. Now that inundates a whole lot of properties upstream, and those properties have to be bought out, and there's usually quite an environmental issue attached to that in relocating communities and so on. So there is a limitation on what can be done, particularly in a built-up or urban area. In terms of sedimentation and dredging, the only one that I'm aware of is smaller dams in urban areas. And the Boksburg Lake was dredged out at some stage, but I'm not really aware of other dredging because of the costs associated with it.
So what then are the other technologies or options available to help combat sedimentation without going through the costly potential dredging of a dam or raising a dam wall?
Right. Essentially what we need to do is to increase the discharge capacity in the dam, quite a large discharge capacity, in order to flush and to carry the flood load, or the sediment load in the flood. And that means it requires something which will open automatically when the flood, when the water levels rise due to a flood. Now in this country we do have an automatic scour gate which has been used successfully at a number of sites, both in South Africa, Lesotho, and now Namibia and Tanzania. These items of equipment have been very effective in keeping the abstraction weir, or the abstraction point behind the weir, free of sediment, because they open whilst the flood is running, whilst the sediment is in motion, either in suspension or it's rolling along the floor, the bed of the river, and is able to therefore pass right through the weir or the dam. And afterwards, as the water level recedes, this automatic gate will close so that the full supply level is retained. We have also noticed that on some larger dams, that if you have an automatic gate which is open during the flood, that the sediment, because it's heavier, carrying sediment, forms a density current, and that snakes its way through the dam, carrying with it the sediment load, the chocolatey water, and passes that through. So even for larger dams, this gate can be effective. Unfortunately, there is a limit in terms of height of about 15 meters, because it's difficult to remove sediment from high up in the dam. But nevertheless, there are numerous dams and weirs which need this type of equipment in order to maintain it relatively free. The equipment can also be used to sluice out existing sediment. For instance, we have dams like Shongweni in KwaZulu-Natal, and St. Giles Isles, who is also in KwaZulu-Natal. That is a 30-meter high dam which is totally silted up. It also has a little hydro power station attached to it, which is now dysfunctional because there's just silt there. It seems that that's a total loss, or total waste of capital expenditure.
Yes.
And it really requires some form of automatic scouring to maintain or to sluice out the sediment and then to maintain it relatively free of sediment. Other big dams which suffer the consequences of sediment is the Volberach Dam on the Culloden River. That is the main water supply to Bloemfontein, and that dam is probably about 90 or 95% silted up. It's lost, I think it was 165 million cubic meters. It's now only in the order of 16 million cubic meters of available storage.
It's a big difference.
Yeah, that is a big problem, and consequently you've had to look at alternative methods to try and supplement water to Bloemfontein. So Danielle, this model explains the automatic scour gate that we refer to. There is a scour tunnel underneath a weir or dam. The scour gate consists of a closed leaf attached to a buoyancy tank, and that all rotates around pivots, pivot axles within a float chamber, a scour gate chamber. The scour gate is protected by a concrete roof over the top to prevent floods from interfering with the mechanism of the gate. The way it works is that as the water level in the dam or weir rises, it gets to an overflow point. Water then flows into an overflow weir, in through a pipe and into the chamber. As the water level in the chamber fills, so the tank floats and it raises the closure plate over the scour tunnel, thereby allowing water at great velocity to flow through underneath the gate and scour out sediment and to move sediment which is in motion at the time. It's very effective in keeping the weir free of sediment. Then as the water level starts dropping, water ceases to flow into the chamber. Then through a series of outflows at the bottom, the chamber starts emptying and the gate will slowly lower itself, thereby closing off the scour gate completely. That then retains the full supply level, but it has effectively opened and closed during a flood to pass the sediment laden water through underneath the dam or weir. These scour gates have been very effective in abstractions to weirs. They can also be manually opened by simply opening a valve. You can flood the float chamber and cause the gate to open and to close again, thereby just flushing out as and when required. As you can see, there's no electrical or mechanical mechanism here to operate it. This is purely automatic and does not require any human intervention. And therein lies its effectiveness, in that it operates when the floods are running in remote areas to effectively keep the weir relatively free of sediment.
So if you were to use one of these gates in a situation like that, more or less how much capacity could be regained, or does that vary dramatically depending on the conditions?
Well, if the the impoundment, or if the structure was built from scratch, and these gates, these automatic scour gates, are incorporated into the structure, then right from the outset, it will maintain the river weir almost relatively free of sediment. There is a weir, a barrage on the Groot Marika River, which has 3 scour gates and 5 crest gates on it. They've been in position now for 25, maybe 30 years, and they work very effectively. Now that there's a pump station attached to that weir, which pumps water to Gaborone in Botswana. So it's a big pump station. It's a very important abstraction, and that weir has hardly silted up. So it shows that these gates are very effective, primarily because they're open when a flood is running and when the sediment load is high and you pass that through. You don't want to allow sediment to settle, consolidate, and then it becomes difficult to move.
Yes. And you mentioned that these automatic gates can also assist in raising a dam wall, so they have a dual purpose then. But how does that compare financially to building a civil structure?
Well, every dam has a spillway, a concrete spillway, and that spillway has a certain capacity to pass the flood. By utilizing some of the freeboard, which is the depth of the spillway, using automatic spillway gates, we can increase the storage capacity. A number of dams have already got this in place, and they've ranged from raisings of as low as 0.3 of a meter, but up to 4 meters. And currently, we're looking at raisings in the order of 8 meters high. Again, this equipment is very useful in that it doesn't require any electrical or mechanical means to operate them. It doesn't require any operators to be present, and they only respond to water levels. So as the water level rises in a flood, so the gate will open, and as the water level drops after the flood has passed, so the gates will close and automatically retain their structure, their supply level. Those gates, combined with scour gates, which are near the base of the dam, provide a very effective combination to keep the velocity moving in the dam and to pass the sediment through the dam. So yes, they are very effective. There is one weir in Zimbabwe on the Rundu River, which has a scour gate, which is in the order of 12 meters wide and 4 meters high, and that has effectively kept that weir free, because in order to move sediment and to keep it relatively free, the weir free of sediment, you need to be able to discharge a large volume in the order of a 1 in 2 year peak flow, and that's a lot of water. So it needs a big dam, a big gate to do that.
Yeah. And in terms of where you've put these automatic gates into an existing dam, what kind of improvement have you seen with moving the sedimentation?
The one just mentioned on the Tswasa weir on Marika, it's the longest one. That has been very effective. It's been in place now for 25 years. Other scour gates that have been installed is in Lesotho, on the Lesotho Highlands Water Scheme. That has been operating now for since 1995, 96. So we're looking at 20 years. And that one worked very efficiently at the time. It prevents sediment moving from a tributary, the Matsuku River, into the Katsi Dam. There is currently a bit of a problem in the intake side of things, so the gate's not working that effectively now, but not due to the gate's problem. It's more an intake problem. But the gate, when it was working, worked very, very well.
And is there a lifespan to these automatic gates, and do they offer benefits in terms of maintenance and things like that because they're not automatic and they don't rely on an operator?
Yes, they offer a big advantage. Nearly all the risk associated with dams is associated with either human negligence or lack of maintenance of electromechanical motors. These gates have no moving part except for the axle unit, and that is, it makes use of a special material called Vesconite. It's a non-metallic, low friction material which doesn't need any lubrication. It just looks after itself. The Department of Water and Sanitation make use of it as well. So the gates require minimal maintenance. The materials are selected based on potential life. The earlier gates were mild steel with a very good protection of an epoxy coating, but more recently we now make the scour leaf in stainless steel, and the top part of the gate, which is not always underwater or in water, in a material called 3CR12. It's also a good corrosion resistant material. That's been installed on a dam in Tanzania with good effect, and more recently, and very recently, it's been installed in a large scour gate on in Nekotau in Namibia on the Fish River. That gate has a scour tunnel of 4 meters wide and 2.3 meters high. So it provides a huge amount of scouring capacity to an offtake to pumps. But the materials are normally selected in conjunction with the client's needs. Yes. But they can last really 20 to 40 years without much without much maintenance.
Which is ideal for our local conditions as well.
It's important, it's essential.
And in terms of these technologies that we have available here, how do they compare to some of the global trends? You did speak a bit about Japan, but...
Yes. Surprisingly, they don't have an automatic gate as has been developed in this country. But then again, in the Western world, they have a higher level of control on their systems. So they rely on electromechanical controls, and the maintenance is obviously in a good position. So there's a higher reliance on it working. Yes. So they use mechanically gates. It's usually a radial gate, or it's a vertical lift gate on wheels, and they're operated by electric motors mostly. So they were the overseas engineers have actually been fascinated at the technology and the effectiveness of these gates, and we find that a number of consultants now are turning to this equipment for abstraction weirs, extraction points on river weirs. That is abstracting water into a pipeline or into a canal or into a penstock for a hydro power station as well. Because sediment, if it gets into a hydro power station, chews up the impellers or the runners of the turbines, and that's costly to replace it. So it's very important to try and remove sediment before it gets to that.
Yes. And I mean, going back to maybe a bit about what we spoke about in the beginning, environmental concerns are becoming more important, and if the sediment isn't allowed to flow naturally through the dam, it affects downstream. So what are some of the environmental consequences if we don't allow for sedimentation to flow naturally through the river systems?
The environmental impacts are quite severe in that we've now stopped the sediment from moving by means of an artificial structure, and but the water still passes over the top. And then, so the water passing over the top has enough power, it then denudes and washes away whatever sediment was downstream before. It also creates erosion of the banks. So some of the structures or whatever alongside the bank can become unstable. But more importantly, the ecology in the river system is adversely affected. They need sandbanks, they need mud banks. It's part of their whole life cycle, and we interrupt that. And those rivers that discharge into the sea, we need to have this sand transported right through into the sea in order to maintain the beaches. There's a literal drift up the coast where sediment is deposited, or sand is deposited onto the beaches and keeps to maintain the beaches. Where that is interrupted, we find there's erosion on the beaches, and that has also been brought to the it's been highlighted in the press, etc. That in some places we don't have enough sand on the beaches, and that's probably because we're not transporting it right down the river systems.
And does that also affect communities? I mean, if you're having erosion of the river banks, there are many communities that are established alongside rivers or close to rivers, so does that have an impact on them as well?
Yes, it definitely does, and it one is safety, but also they have developed a lifestyle of working on the river. They need those banks, those sand banks as well, fishing, etc. So certainly for a long distance below a dam or weir, they are affected by the lack of sediment passing through the system down the river.
Peter, we did touch on this a bit earlier in the discussion, but can you talk to us a bit more about the role of human habitation and the build-up of sedimentation?
Certainly. As I mentioned, before humans came onto the earth, the sort of nature continued with erosion, but maybe more in a more controlled environment because the vegetation was established. However, since we humans have inhabited the earth, and more particularly the last century, with agriculture in particular and development in urban areas, we've disturbed the soil, and that has created a lot more runoff into the water systems. Farming is concerned, even though farmers do contour the irrigation, they do contour their ploughing, it is possible that a lot of erosion takes place from that. But in built-up environments, the surface is broken up with excavators and with bulldozers, road building, and come a heavy storm, that soil gets washed into the drains and into the watercourses. Also, you notice that a lot of the building material gets dumped at a site. Some of it is onto a pavement, and a lot of it is into the roadway. That just gets washed away when there's a storm. So as human beings, we've contributed considerably to the acceleration of sediment in our watercourses.
And does pollution and litter and things like that play a role as well?
Yes, particularly in this country, pollution is one of our biggest threats. Sure, water supply is a threat, but pollution is a significant threat because our dams act as sinks. They capture the pollution that comes through, and that can turn into blue-green algae, which is toxic and difficult to get rid of. We haven't got enough water to flush our dams, and so we need to try and manage that at source. Unfortunately, a lot of our habitation is close to watercourses. We have litter on the streets, which gets washed into the watercourse. We have overflowing sewers, which all end up in the watercourse, and that adds to the significant biological load, which in the case of Hartepeersport Dam, for instance, a well-known case, has resulted in a lot of hyacinth just blooming over the surface. It's affecting not only the recreational use of the dam, properties alongside, but it affects the quality of the water. And that is the water that we need we have to spend more money to treat that water to a standard where we can actually consume it. So pollution is a big problem, and it needs to be addressed by municipalities at source.
So basically there needs to be a big change in human behavior as well to complement the solution to the problem.
Yes, not only that, but also in the use of water. A lot of it goes around education. Education is important. Engineering can only go so far, but we should try and stop it at source. But the other thing with pollution, litter pollution, visible pollution, is that you can see it along the sides of the watercourses. They are caught up in the branches and in the reeds, and it's an eyesore. But that gets carried right the way through into our coastal areas. It clogs up our estuaries. It gets dumped onto the beaches, and they become an eyesore. So there's now a worldwide effort now to try and minimize the use of plastics in particular, but other litter sources as well. We developed a litter trap in Johannesburg, which was very effective in removing a lot of litter, to the effect that after a rainstorm we could take out in the order of 70 to 100 bags of litter. So we need to have more effective ways to remove the litter, accepting that we're not going to be able to educate everybody in a short time. So there are ways and means to try and reduce the litter load and pollution as well. So everybody needs to play their part.
Okay, well, Peter, thank you so much. It's really been a very interesting discussion. And this has been CPD On Demand.
Thank you.